Hello everybody, I'm your host Chelsea Joy here on Cyber Command on YouTube. If you haven't already, please make sure you hit the subscribe button and that notification bell so that you know the next time that I go live after we hit 50 something subscribers, or when the next time I upload a new video. In the previous video, we went over the Internet of Things, neural networks in the context of AI technology, and we went over machine learning. Please check those out. If you haven't already, my next video is going to be about brain-computer interfaces, so stay tuned for that. I'm going to upload that as soon as we get that recorded. In this video, though, we are going to go over what do we need to know about multi-layer perceptron, or MLP, in the context of AI technology, which we learned in one of the previous videos. Make sure you check that out. I'm trying to keep these short. So a multi-layer perceptron, MLP, is a type of artificial neural network that consists of multiple layers of interconnected nodes or artificial neurons. It's a fundamental building block of many deep learning models and is often used for supervised learning tasks such as classification and regression. MLPs are particularly effective in solving problems that are not linearly separable. An MLP is composed of at least 3 layers: an input layer, a hidden layer or multiple hidden layers, and an output layer. Each neuron in the hidden and output layers uses a nonlinear activation function, such as the sigmoid or ReLU function, to introduce non-linearity into the model. Let me repeat that again. Each neuron in the layers of the MLP, especially in the hidden and output layers, they use non-linear activation function, such as the sigmoid or ReLU function, to introduce non-linearity into the model. This allows the network to learn complex relationships between inputs and outputs. Remember, MLP works in layers, kind of like the music lines, where it's one software application or code that does a specific thing on top of another, working in a symbiotic relationship. So the learning process in an MLP involves adjusting the weights between neurons based on the error between the predicted and actual outputs. This is typically done using a technique called backpropagation, which calculates the gradient of the error with respect to the weights and updates them accordingly. This must be talking about the computational algorithmics and the context of mathematics and specific algorithms for the data input. One of the key advantages of MLPs is their ability to learn representations of data that are useful for a wide range of tasks. However, they can also be computationally expensive to train, especially for large networks with many hidden layers. In summary, a multi-layer perceptron, or MLP, is a powerful tool in the context of AI technology, capable of learning complex patterns and relationships in data. It is widely used in various applications, including image recognition, natural language processing, and predictive analytics. Well, what is artificial intelligence, and how does it use software differently from traditional programming? We can go over this again really quick before we go into BCIs, because this is important. Artificial intelligence refers to the development of computer systems that are capable of performing tasks that are typically required by human intelligence, such as learning, problem-solving, decision-making. Unlike traditional programming, which relies on explicit instructions written by a human programmer, AI uses machine learning and neural networks to learn from data and improve its performance over time. This means that AI systems can adapt to new situations and make decisions based on the data they have processed, rather than relying on pre-programmed rules in traditional programming. Now, a machine learner in the context of AI refers to a system or algorithm that enables a computer to learn from data and improve its performance over time without being explicitly programmed as well. This is achieved through machine learning, a subfield of the artificial intelligence umbrella that focuses on developing models and algorithms to enable computers to make predictions, decisions, or carry out tasks based on data and feedback. So the neural network in the context of AI technology is a system or a model designed to mimic the structure and function of the human brain. It consists of interconnected nodes or artificial neurons that process information by responding to external inputs and relaying information between each other. That's a layer of the MLPs. Now, so are MLPs used in BCI technology, which is a brain and computer interface, in the context of AI tech? Yes. Multi-layer perceptrons, or MLPs, are used in brain-computer interface technology within the context of AI tech. MLPs are neural network models that can learn to represent complex relationships between inputs and outputs, making them effective in a wide range of applications, including brain-computer interfaces, BCIs. In BCI systems, MLPs are employed to classify or interpret brain signals, such as those obtained through EEGs or other brain imaging techniques. These signals can be used to control external devices, such as prosthetic limbs or communication interfaces based on the user's thoughts or intentions. That's the kind of technology we're seeing come out in the Neuralink. MLPs help in decoding these brain signals by learning the patterns and features that correspond to specific actions or mental states. For instance, researchers have proposed a subject-independent generalized MLP model to classify motor imagery signals in BCI tech, indicating the use of MLPs in enhancing the accuracy of classification in BCI systems. Moreover, hybrid deep learning HDL models, which can include MLPs, have been employed in BCI systems to improve classification performance. MLPs, with their ability to learn complex relationships, play a crucial role in enabling BCI systems to accurately interpret brain signals and facilitate effective communication between the brain and external devices. Well, external devices that are a part of the Internet of Things that communicate with AI, that will have MLPs running with them or be classified as a BCI themselves, include but are not limited to smart homes and the applications and appliances in the smart homes, wearable devices such as smartwatches, fitness trackers, health monitors, transportation and logistics with vehicle tracking, smart traffic management systems, and industrial IoT, which has to do with manufacturing, smart cities like public transportation systems, smart energy grids, waste management systems. Enhancing some of these devices are being used to enhance the quality of life and sustainability in urban environments. They're also seen in healthcare, remote patient monitoring systems, smart medical devices, telemedicine solutions, trying to improve and enable remote diagnosis and treatment, and agriculture, livestock monitoring systems, weather stations, soil sensors, and then trying to use tech in other ways to optimize farming practices, reduce resource waste, and improve crop yields. The connectivity is achieved through wired connections like Wi-Fi, cellular networks, Bluetooth, Zigbee, Z-Wave, Thread, NFC, and other types of connections. And like we said, the multi-layer perceptron is a type of artificial neural network within the neural network that consists of multiple layers and interconnected nodes of artificial neurons, which is yet another deep dive on how neural networks themselves in the context of artificial intelligence technology are being built to mimic the human brain and interface with the human brain, or maybe a collective human brain, and then individual too, depending on what kind of external device we're talking about. So there's a wide range. So I hope you're taking something from my channel. Please enjoy my other videos and my other content. They'll kind of build on each other and make more sense as you go through. I've been your host today, Chelsea Joy, here on Cyber Command. Make sure you follow and subscribe and hit that notification bell. And again, I'm over on X, platform Cyber Command, with all my other podcasts over there. I would love if you would join me over there too. Hope to see you guys next time.